Right, we're going to look at two examples of graphing a piecewise defined function. So here we have three pieces to this function. First, it looks like a horizontal line, y equals -2. If x is less than or equal to -3. It looks like the parabola x squared when we're between -3 and 2 on the x-axis. And then we look like the line 5x when x is going to be greater than, should say +2, not -2. Let me make that correction here. Okay. So first thing we'll do is we will go ahead and graph the line y equals -2. So that is a horizontal line right here. Okay. I'm just going to graph it all the way out. And then I'm going to pay attention to the restriction. The restriction is x has to be less than or equal to -3. So on our x-axis, we would have to stop at about right here. So we're going to go ahead and do that. So we're going to erase it down to that -3. And because it's x less than or equal to -3, that says we're going to have a closed circle there. And that's it. We've graphed that portion of the graph. Now we're going to do the parabola, and I'm going to graph it just like I graph the parabola normally. So we'll graph it just like we graph a parabola. So 0, 0, 1 and -1. I have output of 1s. And then we plug in -2 and 2, we have outputs 4. 3 and -3 have outputs 9. We're just going to go ahead and graph the parabola like we normally would. So that's all we did there. And then what we're going to do is we're going to go back and erase the parts that are not included. So this is only going to be included from -3 to 2. So we're going to erase some of it. So what we'll do here is we need to come all the way up. Because we start at, let's see, -1, -2, -3, 9 is going to be up here. And I'm going to connect all the way up there. But because we have strict inequality right here, the less than -3, we're going to have an open circle right there. That's what our parabola is going to look like. And then on the right-hand side, we had to stop at 2. Because it told us to stop at 2. Because we have a less than or equal to, we can use a filled-in dot there. Okay. And then finally, we're going to graph the line y equals 5x. So it has a y-intercept of 0 and a slope of 5/1. So we're going to go ahead and graph that. Oops, let's see if I can leave it graphed there for just a bit longer. Alright, and I'm already starting to erase it, but just imagine the line's not broken right now. And it's going to look like this line when x is greater than 2. So we're going to erase all of it up to 2. So we're going to erase all of it all the way up to 2 on the x-axis. And then we're going to put an open circle there because it says x greater than 2, so we're not allowed to be equal to. The domain is everything. The domain is covered by each branch. Any number is either less than or equal to -3, or it's between -3 and 2, or it's greater than 2. So any real number is going to fit in there. So the domain is going to be all real numbers. And that's generally the case with the piecewise defined functions we're going to be graphing. The range is a little bit trickier. The range is the outputs. And we're going to go low to high, and then we have to watch out for gaps. So for the first thing of the range, I'm going to go ahead and put in some values here, is the range starts at -2, but it only includes -2. There's nothing else there. Then we're going to do a union. The union means OR for the jump, and we're going to jump all the way up to 0. And then we're not going to do 4. That's a typo. I'm going to fix that right here. So in this, I don't know, peach colored or whatever you want to call this, pink, we start at 0 and we go all the way up to 9, we don't include 9, so we have an open parentheses there. And then we have a bit of a gap from 9 to 10, and then we pick up from 10 onwards to infinity. And that would be the range. The range is usually a bit trickier out of the two when you're finding the domain and the range. We're going to do one more here. So f of x is going to be equal to, and this is actually one from the notes here, cube root of x if x is less than -1, x squared if x is between -1 and 2, and then it looks like the line 2x plus 5 if x is greater than or equal to 2. So what we'll go ahead and do is we'll draw in the cube root function. So that's one of our parent graphs that we graphed in class, and this is what it looks like. Kind of looks like a propeller or something, but it only exists when x is less than -1. So we're gonna pretty much erase everything up to the -1 right here. So that's what's going to happen here is we're going to go ahead and erase all that all the way up to the -1, and then we're going to have an open circle there. Open circle because it's x less than -1. Okay. Then if we look at the next piece, it's x squared, and that's going to be between -1 and 2. So we'll go ahead and graph it like we normally would, and we'll draw in our parabola. However, it's only going to exist between -1 and 2, so I'm going to stop it at -1, and I'm also going to stop it at 2. So we're going to go ahead and erase most of it down. Okay. At -1, you see it's less than or equal to, so that equal to says we're going to have a filled-in dot. At the 2, it's less than 2, so it's an open circle because it's a strict inequality. Okay. Then finally, we have the line 2x plus 5. So it has a y-intercept of 5 and a slope of 2 over 1. So I'm going to go ahead and draw on that red line. And it doesn't start until we get to 2. So I'm going to erase a bit of the line here. And then we have a filled-in dot because it's greater than or equal to 2. Okay. And that's graphing the piecewise defined function here. I guess we can do the domain and range also. So let's do the domain. Alright, so for the domain's everything. Any real number is going to be either less than -1, or it's going to live between -1 and 2, or it's going to be larger than 2. The range is a bit trickier. It's low to high, and then we have to jump over any gaps. So over here, this arrow is going to indicate that we're going to slowly go down, and the lowest we're going to get is -infinity. Following this branch, you get all the way up to -1, and it's not included, so we have an open parentheses at -1. Then we have a jump, and we're at height 0. And then the highest we go is 4, not including 4, so open circle there. Then we have to jump all the way to, let's see, is that correct? That should be a 9. Let me fix that here. So we should jump all the way up to 9. So we jump all the way up to 9 right here, and then we go off into infinity and beyond. Okay. So that's graphing piecewise defined functions. So if you're doing it in pencil, you can just graph the 2 or 3 graphs that you're going to do, and then just erase the part where it's not included.